Hello everyone. Today's discussion is on Math PSLE 2018 Paper 2. I'm discussing question 1 to 5 for part 1. So the following slides are my suggested worked solutions. Now, before we move on to the suggested worked solutions, please allow me to share the exams SMART strategy. I use the acronym RAISE, R-A-I-S-E. R for read. So we are to read each question very carefully. Then we annotate. A. Annotate by underlining, circling, arrowing, and even any kind of indication to pick up keywords, words that help us to identify. That's the next one, letter I, to identify the concepts, the heuristics that we need to use to solve each word problem. The next stage is to solve. After reading, after annotating, after identifying, we should be able to solve the problem without having to figure out how to go about solving. So we can immediately attack the question because we already know the concept, the heuristic, by picking up the important keywords. Now, after solving, after getting the answer, we are strongly encouraged to evaluate our answers, our solution. Evaluate means to use a different heuristics, a different concept to tackle the same question to arrive at the same answer. Okay, in the next slide, I will be doing questions 1 to 5. Today, I'm discussing questions 1 to 5, as you can see from this slide. Okay, so first and foremost, let's look at question 1. It is a 2-mark question, and we remember that in paper 2, we are allowed to use a calculator. Question number 1. Terry made 90 cupcakes. For every 15 cupcakes, Terry used 3 eggs. How many eggs did he use altogether? Now, using the exam SMART strategy, performing the RAISE, R-A-I-S stages, I have finished reading and I'm going to annotate. Terry has 90 cupcakes. For every 15 cupcakes, Terry used 3. Now, from here, I pick up a very important keyword, for every. Now, when I see for every, immediately I know that I have to apply something related to ratio. So for every is actually involving ratio. That means number of cupcakes to the number of eggs, 15 to 3. I can simplify this ratio to get 5 to 1. That means if I want to make 5 cupcakes, I need 1 egg. Now, Terry made 90 cupcakes. According to the question, Terry made 90 cupcakes. So how many eggs did he use? So here we go. We have the most important ratio. This ratio gave us a very powerful clue. So 5 units is 90. 1 unit, 90 divided by 5, right? That gives us 18. And this is 18. 1 unit is 18. So if we have to make 90 cupcakes, we really need 18 eggs. So I have already answered the question. Terry used 18 eggs altogether. So number 1 is quite easily done. So we just need to pick up the important keywords for every. So when you see for every, immediately we know it is a ratio concept. Question 2. Eric took 2 hours to travel 3/5 of a journey. 2 hours, 3/5 of a journey. He completed the remaining journey in an hour. So we are supposed to find the average speed for the entire journey. Okay, so it is speed, distance, time concept. Okay, so it's a chapter on speed, and we already know we have to use something called the speed triangle. Okay, so we have distance, speed, and time. Right, this triangle should be very familiar with you. Usually it's also found in the textbook, the speed triangle. Now, we are told that there are journey in parts. So let's settle the first part, which is 3/5 of the journey. So I'm going to draw the first triangle for the first part of the journey. So this is Eric's first 3/5 of the journey, and he used 2 hours. Okay, all right, then we also need another triangle for the remaining journey, remaining 2/5. So if you notice the journey, right, it is written like a part whole fraction. So first journey, 3/5 journey, that's the first triangle, and the second triangle shows 2/5 journey. So in total, there should be 5/5 journey, which is indicated here. So that's a whole. Okay, now I have already slotted in the first set of information from the first sentence. The second sentence tells us he completed the remaining 84 km. So that means the second journey, 2/5 journey, should be 84 kilometers. Okay, so using this idea in mind, I can start my first equation. So 2/5 journey is 84 km. So 1/5 journey will be 84 divided by 2. That gives me 42 km. All right. Now to find Eric's entire journey, the average speed for the entire journey, okay, we need to know the total distance. So total distance is 5/5 journey. This is the total distance. So 5/5 journey will be 42 times 5. So 42 multiplied by 5 gives us 210 km. Okay, all right. Okay, and now I'm going back to my second triangle. Eric completed 84 km in 1 hour. So this is 1h. Okay, so to find the average speed, Okay, to find the average speed. So average speed is actually equals to total distance divided by total time taken. So total distance equals to 210 km divided by total time taken is 2 hours plus 1 hour, that is 3 hours. Okay, so we got 70 km per hour. So number 2 is completed. So number 2 is a speed chapter involving part journey by parts. Question 3. Now, question 3 is a true false not possible to tell question involving algebra. So the topic is on algebra. So it's always very, very good. Besides identifying the concepts and the heuristics, we also need to know the topic. Okay, for a recycling project, Ali collected 12 bottles. So I'm going to do annotating 12 bottles. That's for Ali. Bala collected 2M bottles. And we have another character. Carl collected 2 plus M. I'm going to put all this into a listed information. Ali, A for Ali, 17 bottles. B for Bala, 2M bottles, and Carl, 2 plus M bottles. So these are the info that I have gotten from the question. I'm going to use the info to answer the 3 statements. Statement number 1. Ali collected the most number of bottles. Now, we can't tell whether Ali collected the most or not. Ali is the only information that we have, 17. Ali's number of bottles is a whole number. It is not an algebraic expression. Now, we can't tell whether he has the most or not because the value of M is not given to us. Right? If M is very big, then Ali may not have collected the most. Alright, for example, if M is 10, then Bala will have collected 20. So the first statement is definitely not possible to tell because of we are not sure what is M. So I'm going to write down here what is M. Okay, M is unknown. If M is unknown, it's a lack of information. Now, statement number 2. Bala collected more bottles than Carl. Okay, let's find out. Is it really true that Bala collected more than Carl? Okay, so we have to give M a value. Let's say M equals to 1. If M is equals to 1, Bala will have collected 2 times 1, that is 2. And Carl collected 2 plus 2, that is 4. So when M equals to 1, Bala actually collected less, fewer. Okay, now if M is equals to 2, Bala collected 2 times 2 equals to 4, and Carl collected 2 plus 2 equals to 4. The same. So actually, it's really lack of information again, because we need to know what is M. So it's not possible to tell for statement number 2. Now for statement number 3, the 3 boys collected 3M plus 19 bottles altogether. Okay, let's add this up. Okay, so 17 plus 2M plus 2 plus M. Okay, so let's add the whole number term first. Okay, the non-algebraic term first. That means 17 plus 2, that gives us 19. Now, we shall add the algebraic term. 2M plus M is 3M. So putting these two together, we have 19 plus 3M, or 3m plus 19. Statement number 3 is true. Number 3 is done. Question 4. Now, question 4 involves area of a rectangle. Okay, so the concept is area. Let me write down. The concept is area. Okay, so it involves length times breadth. Okay, now the question reads this way. Two rectangular mats, each 6 meters by 4 meters. So 6 meters must be the length, 4 must be the breadth. Okay, now they are placed on the floor as shown in the diagram. The mats overlap each other. It overlaps here. This part. This part is the overlapping region. Okay, it overlaps there. Now the area of the floor covered by the overlap is 5.2 square meters. So this is provided. Find the area of the floor not covered by the mat, by the two mats. So to do this question, what we can do is, we know that the two mats are overlapping each other. So I am going to redraw this picture a little bit bigger so that it facilitates explanation. Okay, so give me a minute. So I'm going to re-sketch. So something like this. Okay, all right. Okay, I'm going to use two different colors for the mat. Two different colors. So the first mat, let me use this color. Let's say it is here. Okay, all right. Okay, I think it's too big. Let me remove this part. Okay, can. All right. So let's say the first one, okay, this is the one. Okay, this one is the first one. Okay, the second one is this. Here. All right. So they overlap each other. Okay. Now I'm going to put in all the information. So this is 6 meters. This is 4. Then this is for the mat that is lying down. Then for the mat that is standing up, this is 6. Oh, my apology. 6 ends here. 6 ends here. Right. Okay. And this is 4. Okay. I hope it's clear to you. Okay. 6 ends here. 4 ends here. And then this 4 ends here. And this is very clear cut. It's the whole thing. Okay. Now, to tackle this overlapping figure, all right, what we need to know is that this portion here, I'm going to highlight it red. This one is double layer. Okay, double layer, why? Because the first layer belongs to the rectangle that is upright, and then the second layer belongs to the one that is horizontal. Okay, now let's find the area of one rectangle first. So area of one rectangle, 1, is length times breadth. That gives us 24 square meters. Okay, so we know the value of the area of one rectangle, one mat. Now, to do overlapping figures, I would like to introduce you to a method of solving. Split the figure into 3 parts. This is A. A is actually here. Okay, and the red portion is B. Okay, and then this part, the L shape, is C. Okay, all right. So split them up into 3 parts. so that we settle them in separately. So okay, if I may do this, all right, so this 24, right, this 24 square meters belonging to both rectangle. Okay, so if I look at the upright rectangle, it is made up of A and B. So A and B together is 24 square meters. If you look at the one that is lying down, B and C is also 24 square meters because they are identical maths. Now, something is repeated. This. So this is called repeated identity. So it's a repeated identity concept. Okay, it's a repeated identity concept because the overlapping portion is the repeated identity. In this case, I call it B. I name it B. Okay. Now, we all know the value of B already. B is given to us. B is 5.2. So the value of B, I'm going to write down here. B is 5.2 square meters. So from here, I can find what is A. So A is 24 subtract 5.2. So what is A? A is 18.8 square meters. We know B. We know A. Let's find out what is C. So C is 24 subtract 5.2. C is okay, right? 24 minus 5.2. So we know C is actually 18.8 square meters. So this is C. I'm going to box it up again like what we have done for A, B, and C. So we have three different portions for the whole figure. They are split into three portions, A, B, and C. Now, to find the area that is not covered, okay, which means we want to find this part that I'm going to color it yellow to find this one. Okay, to find this one. All right. So to find that one, what we can do is we know that, okay, we know that the whole figure, okay, we know A, we know B, we also know C. So this 18.4, okay, which is figure C, okay, 18.4, 18.4 also belongs to A, all right, 18.4 belongs to A, the one that is in purple. Okay, let me show it to you. 18.4 is here, this one here, all right, okay, so if you take 18.4 divided by 4, 18.4 divided by 4, we can find what is this. This one, we can find this part. So 18.8 divided by 4, that gives us 4.7. So this is actually 4.7 meters. And we already know this is 2 meters. So the one that is in yellow is actually found, the uncovered portion. So the uncovered portion is 4.7 times, okay, let me use a different color. 4.7 times 2. So 4.7 times 2 is 9.4. Right? Okay, we have already found the answer. So the answer is 9.4 square meters. The uncovered area of the floor is 9.4 square meters. This part here. Okay, this part here. Okay, this is 9.4. Right, so number 4 is done. Okay, feel free to play back the video to further understand question 4. Okay, right. Question 5, the last question for this video. Ken had $15 more than Lisa at first. After Ken gave some of his money to Lisa, he had $21 less than Lisa. Okay, so very powerful information here. Ken gave to Lisa. So when Ken gave to Lisa, it is the concept of internal transfer. So internal transfer means total unchanged. So it's a total unchanged concept. So I'm going to draw the model to show the first information, the before model. Okay, that's right. So Ken and Lisa, Ken had more, like that. Ken had more. So this would be my $15. 15 more than Lisa. Now Ken gave some to Lisa, and then in the end Ken had less. Okay, so let's say Ken gave this away. I'm going to cross it out. So this is given to Lisa. Okay, and Lisa received this from Ken. I'm going to extend this. So this is from Ken. Okay, now after Lisa received from Ken, we have the final information. Ken had $21 less than Lisa. Okay, so where is this 21? This 21 is from here until here. This whole thing is $21. Okay, right? So Ken ends here. So that's why you must start from here. And Lisa ends here. That's why you must end here. So start and end. So that's your 21. Okay, now one thing for sure, we all know very well that this red portion here, all right, this red dotted rectangle here is same as the one that is crossed out. Okay, it's exactly the same. So I can conclude that this is equivalent to this. Okay, so what is 21 actually? 21 is made up of 1 unit plus $15 plus 1 unit. That is our 21. So 21 is actually 2 units plus 15. So 2 units is 21 minus 15. That gives us 6. So 1 unit will be 6 divided by 2. That is $3. Okay, right? So this part is $3. Okay, let's go to the question. How much money did Ken give to Lisa? So the one that is in red. So the one that is in red, cross out, you get to see this one here. Okay, I'm going to write up above here. It's actually 1 unit plus 15. So 3 plus 15, that gives us $18. So $18 is the answer for number 5. So number 5 is done. Okay, yeah, that's all for my video for today on PSLE 2018 paper 2, question 1 to 5. It is the part 1 of the 2018 paper. Coming up next, there will be 5 more videos, as you can see from this particular slide. Okay, all right. Now I hope today's explanation, today's video is clear to you on how to solve the question 1 to 5. Okay, if it's okay, you find it very clear, and the explanation is easily understood. And most importantly is that you get to learn a new method of solving, okay, and it's a easier understanding method. All right, and also the exam smart strategy that I've shared with you, RAISE, is indeed a very useful strategy. If you like today's video, click on the like button, share with anyone that will benefit from this video, and don't forget to subscribe so that you get to receive notification for the other parts 2 to 6. All right, for question number 6 all the way to question 17. Thank you for watching. Thank you for your attention. Take care. Goodbye.